As you look at different motherboards, what you will find is that the memory slots on these motherboards may be different. That's because through the years, the standards have changed dramatically. There's many different kinds of memory slots, and even the memory that's going into that memory slot may be a little bit different from motherboard to motherboard. It's this need for speed, this need for faster and faster computing that really drives the changes that we are making to these memory slots and these memory technologies. This connection between memory and the CPU has a dramatic impact on the performance of a computer. That's why we change these memory types over time, because if we can make that path a little bit faster, we can improve the overall performance of your computer. So check your memory configuration and see what type of memory you might be using. You may have to go to your motherboard manufacturer and look at the documentation itself. It will tell you exactly the type of memory you should need. And that's important to keep in mind because memory may look identical. You may have memory that will fit into many different motherboard slots. But the memory characteristics themselves on the inside of the memory are the things you can't see. And just because a memory happens to fit onto one of these motherboard slots doesn't necessarily mean that memory will work on that motherboard. You have to check your motherboard documentation, check the documentation of your memory, and make sure those specifications match so that the memory is going to work properly in that motherboard. It is unlikely you will ever see this single inline memory module or SIM on any modern motherboard. In fact, it's hard to find on any old motherboards. This is one of the very first types of memory that was packaged this way, where everything was on one memory module. Prior to this, we had some memory modules where we had pins on the bottom. Some memory chips were separate chips, and you had to install separate chips onto a motherboard. And finally, we were getting to the point where this was modular, where all the chips could be packaged together, and we could use one standardized slot to simply plug that memory in and be able to use it. You can see for a single inline memory module that is referring to the contacts that are at the bottom of the module. These contacts that are at the bottom are the same on both the front and the back of the memory module. If we were to look at it, it has this same connector that is shared across the front and the back. And that's why we call this the SIM, and that's where that single from the SIM comes from, that single inline memory module. There were different kinds of memory modules like this. This is the 30-pin version of the SIM. There were also 72-pin versions of this SIM, but this is an older style of memory. You don't see this memory package any longer, but it's one that you may run into if you get a very, very old system. You may find that you'll have SIM modules on there. Unfortunately, you won't be able to buy any brand new SIM modules. You'll be able to find some on the used market, and generally those computers are so old that you won't have to worry about doing any memory upgrades on those. One important thing to remember is at this time, we were just trying to figure out how to put these packages together. There were no standards across the entire industry. Some SIM modules worked on some motherboards, some SIM modules worked on other motherboards, and you couldn't swap them. Even though they looked identical, they seemed to be the same, but they weren't following a very strict standard. So keep that in mind if you ever are in a situation where you're working with these single inline memory modules. The Rambus Inline Memory Module, or RIM, is a standard that was created by Rambus, and it's not one you find on a lot of modern computers, but you do seem to have a number of older computers where you might run into this from time to time. There are 16-bit versions and 32-bit versions of these memory modules, the 16-bit being 184 pins and the 32-bit being 232 pins. And you'll hear these referred to or see them written as Rambus Dynamic Random Access Memory, or RDRAM. If you have RDRAM in your computer, it's referring specifically to this Rambus memory. What's interesting about this Rambus memory is that it required that every memory slot in your computer be occupied with a particular memory module or a continuity RIM. And sometimes these are called continuity and termination RIMs. So you don't have to put actual memory in every memory slot on your motherboard, but you do have to put at least memory and some continuity RIMs on them. And so if you ever see a motherboard that has these RIM modules on it, one thing you'll find is every slot is filled. Every slot doesn't necessarily have to have a memory module inside of it, but you do have to have what's called either a continuity RIM in the case of 16-bit modules, or a continuity and termination RIM in the case of 32-bit modules. Every slot had to have at least a memory module or had to have these continuity RIMs inside of it as well. These are to make sure that we're able to fill up everything that's on the motherboard. This type of standard required that you have that continuity across all of the slots of memory. If you left out a continuity RIM, that memory would not be able to operate. So you either filled up every module with actual memory, with actual RAM bus inline memory modules, or you filled up a couple of modules with the RAM bus inline memory module, and then you filled the other modules with these continuity RIMs. So if you're working on a motherboard, you notice that some memory slots have memory modules in there. It's obvious that's a memory module, but other slots have what looks like a memory module, but it's really just a stick that has no memory on it. It looks like it's a completely blank memory module. Well, that's a continuity RIM. And what you're dealing with there is a system that is using this RAM bus inline memory module as the memory for this motherboard. If you're working with modern motherboards, then you're most likely going to find dual inline memory modules on those devices. These are the modern memory types that we see today. This dual inline memory module means that there are contacts that are separate on each side of the memory module. So you can see all of the little copper contacts at the bottom. On the other side are another grouping of contacts, and they don't meet. They aren't part of the ones that are on the front. So the front contacts and the back contacts are completely independent. They are dual inline memory modules. Unlike the older memory modules that had 16 or 32-bit data widths, these DIMMs allowed us to have 64-bit data widths. So we were able to send a lot more information across the bus in a single clock cycle. So you see these DIMMs used in SDRAM, that's 168 pin. There's DDR, that's 184 pins. You'll also see it in DDR2 and DDR3 memory modules. Those tend to be 240 pins wide. As we become more mobile, we've needed to take the same amount of capabilities with us wherever we go. So we needed to take the memory that we were using on our desktops and put it into a much smaller package. And so we came up with the SODIMM, the small outline dual inline memory module. The small part means that we have shrunk down the package so that it will fit into these mobile devices. And you'll find a lot of different versions of this for DDR and DDR2 and DDR3 and different pins, everything from a 72 pin, a 100 pin, 144, 200, and 204 pin versions. And we're using these on our laptops, on our mobile devices, on anything where we wanted to take the same capabilities, but have it in something that's much smaller and much more mobile. So what type of RAM slot is in your motherboard? You should now be able to look at all of these different memory module types and be able to understand exactly the memory that you'll need for your motherboard.